I think it's a similar art design. Yeah, so they did it in a Futurama kind of esque style. Yeah, as the quotes from, because in the show everybody's assigned the job they're best fitted to, and he got assigned a delivery boy or be a delivery boy. Futurama, Leah, and he asked like, "What if I don't want to do that job?" And they're like, "Well, you'll get fired." Into the sun. All right, guys, we're going to go on and get started on the note sheet. So this is where we stopped yesterday. And as we've seen so far with most of these here, we end up graphing them to try to get solutions. Out of this here, we're going to need 4. We need to find 4 values of x. At minimum, we need 2. Because if I can get 2, we can take it from a degree 4 down to a degree 2, a quadratic. We have ways to solve a quadratic. What would be even better is if we get 3. Because if we get 3, we're down to just linear terms. So something like 2x plus 4 is equal to 0. Those are easier to solve. Those from yesterday are 4 or 5. Okay. Because if we get it down to a linear, so something like 2x plus 4, set it equal to 0, solve. And the best case is if we get 4 from the beginning, because if we get 4 solutions, those are the solutions and we're done. So 4 is the best case, 3 is not as good but better than nothing, and 2 is the minimum we need. So we need at least 2, 3 is better, 4 is the best. So first thing we can do is graph this. So in the graphing calculator, we'll hit y equals 6x to the 4th minus 11x cubed minus 16x squared plus 2x plus 4. Graph. And I believe we saw this graph yesterday. Yes? And we can see here, it doesn't look like it intersects at any nice points. We can look at the table. Well, we do not have any y values listed here that have a value of 0. So we aren't shown any values of x that make the function equal 0 yet. There are 4, and we're going to need to find them. So what we're going to have to do to find these is go to our rational zeros. Our plus or minus p over q, where p is the factors of the constant term and q is factors of the leading coefficient. Everybody have a calculator that needs one? Yes? So p, we'll start with p. Factors of the constant term are 4. Well, that'd be 1 and 4 and 2. Now it is technically 2 and 2, but again, as we said yesterday, any factors that repeat, we're not going to list them twice. And just having both 2's isn't going to add anything, because anything the first 2 will give us, the second 2 will also. So we only list it once. Leading coefficient is our 6. And factors of 6 are 1 and 6, 2 and 3. Questions on how we found the values of p and q? Plus or minus p over q. So we're going to take each of the factors of p and divide it by each of the factors of q. Now I normally do this one q value at a time. So we'll have plus or minus. Our 1 divided by 1 is 1. Plus or minus 2 divided by 1 is 2. And then lastly, plus or minus 4 divided by 1 is 4. With our rational zeros, we will always get plus or minus just the values of p listed every single time, because we're always going to divide it by 1. Now at this point here, we move to the next value of q, which is 2. So we would do 1 divided by 2. which is plus or minus 1/2. We'll leave them in fractional form, and if we can reduce them, we want to reduce them. The next one would be plus or minus 2/2. 2 divided by 2 is 1. Do we already have it? We're not going to list it again. And then we have 4 divided by 2 is, we already have it. We're not going to list it again. Now we're going to move on to 3. So we have plus or minus, because then we do our 1 divided by 3, which is 1/3, 1/3. Then we move on to the next one, plus or minus 2/3 is 2/3. And then lastly, plus or minus 4/3. Well, the reason we didn't have to list out all the ones for 2 is, well, 2 and 4 had a common factor of 2, so they reduced. 3 does not have any common factors with 1, 2, or 4, so we had to list them all out. Now our last one is 6. So the first one we're going to have is plus or minus 1/6. 2/6 would reduce to 1/3, and 4/6 would reduce to 2/3, and we have those. Now, if you don't see those reductions immediately, put them in a calculator. Use our fraction key, put in each one. If it reduces, the calculator will reduce it for us. If it doesn't, it'll just give you back the same fraction. Does that make sense? Questions on this here? Now, part of the reason I do one value of q at a time with all the values of p is because it will show us any that reduce. And we don't have to list them all out, then remove the ones that got repeated. And it gets us a more nice, orderly frame. Now, at this point here, we're going to be using the graph and these rational zeros in combination to find solutions. Well, the first three we have is positive -1, positive -2, and positive -4, yes? Well, if I look at the table, positive and -4, neither one of them gave me a y value of 0, so they're out. Positive and -2 did not give me a y value of 0, so they're gone. Positive -1 did not give me a value of 0, so they are gone. So out of all of our solutions, those three are immediately out because they do not give me a y value of 0. Now we can look at the rest of them. And one way that's very good to look at is see where these are on the x-axis as well as where the graph crosses the x-axis. So we do have a majority between 0 and 1 and 0 and -1, yes? 4/3 is too big, but it's actually not big enough to be the last one, is it? Because that farthest to the right is greater than 1, is greater than 2 but less than 3, yes? 4/3 is greater than 1 but less than 2, so it doesn't line up with that. On the positive case, negative case, there's nothing in that spot either. So what can we say about 4/3? That's gone. If we wanted to check it, we could. In the calculator, as a reminder, second trace, our calculate value, 4 divided by 3, does not give us a y value of 0. Second trace value, -4 divided by 3. Also does not give us 0. So those are out. Give us, or pick one of those other values. 2/3. Second trace value, 2 divided by 3. That's not it, but we also have what? -2/3. -2/3 works, so we know one of the solutions so far is x equals -2/3. We know positive 2/3 is done because it didn't work. Is there another one we want to try before we start synthetic division? 1/2. trace value. 1 divided by 2 is 1/2, so y value is 0. We can do negative 1/2. Alpha. Second trace value, negative 1/2. This is this here. And we can do the other values. 1/3 does not work. Negative 1/3 does not work. We did 2/3. I think the last one's 1/6, isn't it? So none of the rest work. Now, kind of, we'll get this theorem. We kind of already talked about it and danced around it. But we noticed that the one solution that was farthest to the right was not any other rational, correct? Rational zeros will give us all the rational solutions, which means that point that crossed farthest to the right is not rational. It has to be irrational. Irrationals always come in pairs. So if we have one irrational solution, we have to have a second. And since we have 4 solutions, we've taken away the 2 rational. We have to solve it for the irrational. So most likely, none of them line up to it. There's a good chance it's irrational. I don't know why I just put the 6 there. 6, negative 11. I'm going to do 1/2 first. And again, most of these here, doing the synthetic division, the calculations, you can do these in a calculator pretty nicely. Because the first thing we can type in is 1/2 times 6. 1/2 times 6 is 3. We put it under the negative 11. And in the calculator, you can hit plus negative 11. And it'll tell you it is negative 8. At this point in the calculator, you can hit times 1/2. It'll give you negative 4. Then you can immediately hit plus negative 16. And the calculator will tell you it is negative 20 times 1/2 plus 2 times 1/2 plus 4. Now you don't have to keep retyping the number in, because if you hit an operation sign immediately, don't type anything in, hit an operation sign, the calculator is going to say A and S, then that operation sign. So it's grabbing the previous answer. So if you did 1/2 times 6 to start with, it gave you an answer of 3. As soon as you hit plus negative 11, A and S, previous answer was our 3. So it's going to add it to it. Times, add, or subtract. And it'll do it for you really quickly. Now we were expecting a remainder of 0 because we knew 1/2 was a solution. And we're going to do it again with negative 2/3. Negative 2/3 times 6 is going to be negative 4. Negative 8 plus negative 4 is negative 12. Negative 2/3 times negative 12 is 8. Negative 20 plus 8 is negative 12. And negative 2/3 times negative 12 is 8, which gives us a remainder of 0. Truth be told, I didn't do those calculations in my head just now. I knew what they were from yesterday. Do a problem 3 times in a day, you kind of remember what the numbers are going to be. But questions on how we got to this here? We ready for the next step? So we have 2 of the solutions, and we have it as a quadratic. So what we're going to do is plug our variables back in. The number in the box is our remainder, which is 0. It should be 0 because it is the last 2 have been solutions. The number in front of it, our first negative 12, is our term without x. The second negative 12 is our term with x, and our 6 is our term with x squared. If there is a greatest common factor, a number that is divisible by every single term, get rid of it. And we're going to divide the whole thing by 6. Even the 0. Because our 6x squared divided by 6 is x squared. 12x divided by 2 is 2x. And our 12 divided by 2, or 12 divided by 6 is 2, giving us 0. What this does is it helps reduce the likelihood that we will have to simplify a like term out at the end. Doesn't reduce the probability to 0, but it does reduce it. Because our 6x squared minus 12x minus 12 has a 100% probability there will be a common term in everything that we would have to reduce in the end. Here, we've reduced that likelihood. Now, we're going to have to use quadratic formula. Now, we can check and see using the square root part of the quadratic formula, square root of our b squared minus 4ac, because a in our case here is, b is negative 2, and c is negative 2, because this is lining up with our ax squared plus bx plus c. A is the number in front of x squared, b is the number in front of x, and c is the number without a variable. So we have a, b, c. So the method I talked about the other day is we could say second square root of negative 2 squared minus 4 times 1 times negative 2 tells us it's 2 square root of 3. That's a radical, that's a decimal. It means this doesn't factor. Kind of also tells us what part of the answer is. Let's go back over here. X is equal to negative b. Well, that'd be negative 2. Or we could say it's just 2. Plus or minus square root of minus 4 times a, which is 1, times c, which is negative 2, all over 2a, 2 times 1. As we just said a minute ago, our negative 2 is 2. The denominator, 2 times 1 is 2. At this point here, we could plug everything inside this radical into the calculator. Actually, at this point, we don't need to. We know what this is. Because what did we just type in to see if it was factorable? Square root of b squared minus 4ac, yes? Calculator told us the whole thing was 2 square root of 3. It does work out. You don't have to write this step down, but the in-between step is that this actually reduces to the square root of 12, and the square root of 12 reduces to 2 square root of 3. Because 12 is 4 times 3, square root of 4 is 2, can't take square root of 3. So the 2 comes out, 3 stays in. Questions on this here? I will say this is reducible. Look at the top 2 numbers. We're going to divide everything by 2. I'm going to do an in-between step, so this makes somewhat more sense. Really what we're doing is we're splitting the fraction. Like if you combine fractions, we add the numerators, denominator stays the same. We can split it apart. First part, 2 divided by 2 is 1. Again, our 2 over 2 would reduce to 1, leaving us with square root of 3. So 2 of our answers are 1 plus or minus the square root of 3. And we also have that x is 1/2 and negative 2/3. So those are our 4 answers. Mm-hmm. Right, the plus or minus, because we're looking at this, because it's saying x is 1 plus the square root of 3, and x is equal to 1 minus the square root of 3. Questions on this here? So, and again, we'll get to this even more in chapter 4.6, dealing with these here. But the first place I always go when solving these higher degree polynomial functions or trying to solve them is to the graphing calculator. Because if there are nice zeros, nice solutions, let it get them to us, get them for us. Because whatever the degree is, if I can find at least 2 less than whatever the degree is, so if it's a degree 5, if I can find at least 3, degree 6, if I can find at least 4, that's great because I can get it down to a quadratic. If I can find the number of solutions equal to 1 less than the degree, that's even better. And the best option is if it gives me all of them immediately. Let's look at this one here next. X cubed minus 5x squared minus 2x plus 24. X cubed, x squared. I believe it was 2x and 24. Okay. That one's a copy of a copy, so it didn't come out well. Graph. I think I'm a little off. Minus. That's why. It was 2x, but it should be. We see it intersects the x-axis in 3 places. We needed 3 places. So the solutions are what? 3, 4, and negative 2. We needed how many? How many do we have? 3. So we are done. That's it. Questions on these here? You know, this one here, we needed at least 1. 2 would have been great. 3 is the best option. Last theorem we're learning in 3.5, the irrational conjugate theorem. And this whole theorem, you don't have to write the whole thing down, but what it's mainly saying is that if a plus the square root of b is a solution, a minus the square root of b is a solution also. As we saw with the first problem we did today, we got 1 plus the square root of 3 as a solution, yes? And according to this theorem, 1 minus the square root of 3 is also a solution. If we have one, we have to have the other. That's also part of the reason where I said that one value was way far to the right, did not match up to any rational solution. So there's a good chance it's irrational. Well, if that's irrational, it means we have a second one. They always come in pairs. And that's part of the reason that if we know this here, once we found 2 solutions and notice one's probably irrational, I'm going to stop looking after that. Because we have a total of 4, we found 2 rational, third one's probably irrational, which means the fourth one has to be irrational as well. And I mean, this could also be square root of 2 is a solution, negative square root of 2 is a solution. If we have one, we have to have the other. Questions on this here? Okay. Last thing we're doing is not going to involve solving of any kind. We're not finding values of x. We're finding the polynomial. We're going the other way around. Because in the first problem we did today, they gave us the polynomial equation and asked us to find its zeros, asked us to find its solutions. Here, they gave us the solutions. On the homework, it's just going to tell us what x is equal to. So it'll start about right here. And we want to find the polynomial equation that these attach to. Now, the whole wording up to the top, find the polynomial of least degree, all that's saying is each one of these zeros only shows up once. If it's listed twice, that's as many as it shows up. And we're not going to multiply it by a number. I will show that in the end. but we have these two as solutions. But it does mean we have a third one. Because if 2 plus the square root of 5 is a solution, 2 minus the square root of 5 has to be a solution as well. How many solutions do we have? Which means our final polynomial function should be a degree 3. 3 solutions, degree 3. Questions on how we got this started? Luckily on the homework, all you'll have to do is add the conjugate to it to get started. Now at this point, what we need to do is to get these in factored form, or really we just need to get them equal to 0. We need to get everything on the same side. So for our x equals 3, we will subtract 3, telling us x minus 3 is